let's remember the formula for area and circumference of a circle. We've got area is pi times the square of the radius, and circumference is 2 pi times the radius. Or if you prefer, pi times the diameter. Both of those for the circumference mean the same thing. It's just sort of rewriting the same thing differently, right? But either way, we're going to go through and we're going to calculate. Let's start with this first one. We've got our area. Well, our radius is 12 inches. We're going to do pi times 12 squared. 12 squared is 144. And then just leave the pi. So one of the things that I want to clear up today, unless you are specifically told otherwise, leave your answers in terms of pi. That is to say, instead of doing 3.1415926 times 12 squared in your calculator and getting some big ugly decimal, please feel free to just leave it as 12 squared, which is 144, and then put the pi on it. And just leave it that way. It will be understood that the answer is actually a little bit more than 3 times bigger than 144, right? So please feel free to do it like this. A, easier for you. B, less messy. And C, I got you. Less you have to deal with just in general. So please feel free to leave it this way. Likewise, circumference. Now you have these two different formulas up here. Now, I'm not going to tell you how to keep things in your brain, but what I will say is it does help to have both things in your brain. That way you can sort of do the best thing for you. There's going to be times when they're going to give you the radius or they're going to give you the diameter. And if you spend all your time recalculating the other one, just to put it back in anyway, can sometimes be a little bit extra. You know what I mean? So 2 pi times the radius versus just pi times the diameter. You're going to get the same answer either way, but sometimes it does help to have both sitting there. That way you can use the one that you've got, you know? And that's my opinion on it. If you want to go through and just pick one and say, I always want to just make sure I have the radius. And if they give me the diameter, I'm going to calculate the radius and then I'm going to put it in. That works too. Yeah. But sometimes if you're just doing one and then you've got the other one, it's like going around the block to cross the street a little bit. So just be aware of that. No one's saying you're wrong. You're going to get the same answer either way, right? So we've got 2 pi times, in this first one we got 12. So 2 times 12 is 24 pi, right? So that's what we got for this first one. We got the area is 144 pi. And the circumference is 24 pi. With the second one, same thing, just with different numbers. We got 32 centimeters in this case for our area. Pi times 32 squared. And if powers of 2 are really great things, if you recognize it's a power of 2, you can just multiply by 2, cut on your fingers and toes, right? So 32 is 2 to the 5th, so I'm just going to multiply 32 by 2 5 times. 64, 128, 256, 512, 1024. All those years playing 2048 for like 3 hours at a time helps make this a lot easier. All right, circumference, same idea. 2 pi times the radius. 2 times 32, we get 64. don't forget the factor of pi that's in there, right? So each of these numbers are actually 3 times bigger, right? So this first one is actually something closer to 3,100. This one is a little bit closer to 200, right? So just be aware of that. The people occasionally will just like drop the pi off because they've been doing all the arithmetic in their head, and that's great. But you got to remember that pi is a number that's being factored in, and we're writing it on the side to make it easy for us, but it's no different than like a radical 2 or some other irrational thing that we put out there so we don't have to worry about calculating an ugly decimal. So just be aware, it does matter. And I've seen people just sort of forget about it. So just keep in mind, it is there on purpose even. Alrighty. Last one. Here we're given the diameter, 1 meter. So we're going to have to figure out the radius to be able to do the area, right? Well, if the whole thing from one end to the other is 1 meter, then the radius, which is halfway, is 0.5 meter, right? And again, you know, this is purely personal preference, but I'm always of the opinion that writing fractions, especially when you have to do stuff like squaring, makes life easier. But if you're a decimal person, you know, I'm not going to stop you from getting the same answer that I get up here. Because either way, you're going to get here 1/4 pi, or as you will find in pre-calc, we like to put pi in the numerator, like this, pi over 4. A lot of pre-calculus textbooks will write the numbers like this, and something, especially pi over 4, because pi over 4 is really common when you're talking about the unit circle. When you get to more advanced trigonometry, that's the way to write it. But if you end up with 0.25 pi as well, that is also okay. For that should be an A for area, right? I'm so excited to get to circumference, because circumference, we're given the diameter. Just use the diameter, right? Diameter is 1, ain't it? Don't divide by 2 only to multiply by 2 again. This is just 1 pi, or that is to say pi. Ooh, that pi didn't look so good. Let's try it again. A little bit better. I need to work on my Greek handwriting. But anyway, yeah. So here, where we've got a diameter of 1, our circumference is 3.1415926. All right, let's continue. So what are we doing today? We're going to be able to find the arc length of a circle. We'll talk about what an arc is in a second, but it's basically just a piece of a circle. How are we going to find this? We're going to find the percentage of the circle that the arc covers, and after finding the circumference, multiply by the percentage. That's a lot of words. Don't worry, it's super easy. Why are we doing this? Because, again, the book is going to try and use a bunch of words to make it seem like this is difficult. This is super easy. We're going to work in terms of circumference, a thing that we learned as little kids, and we're going to think about arc length from the perspective of circumference. So we don't have to actually do a lot of thinking, you know? Ain't nobody want to think right now. But anyway, so let's talk about what an arc is, all right? So an arc is just a segment of a circle, right? You know, we talk about lines and then we talk about line segments. An arc is basically just, you put 2 points on the circle and then the part between them, that's an arc. So when we're talking about a type of arc, and this is sort of almost a distinction without a difference, because there's not like, it's not like with a ray, a line, or a line segment where the three things are astronomically different from each other. Like one of them goes off into infinity both directions. One of them goes off to infinity in one direction. One of them doesn't go off to infinity at all. It's a finite measurement, right? However, with this one, it's just different sizes of the pieces of the circle. And we're gonna, more for the sake of communication and being able to notate them and have us look at them and go, oh, it's this piece as opposed to this piece, we basically made up three categories. You've got major arcs, which basically the distance that you traveled was more than half of the circle. Minor arcs, the distance that you traveled was less than half of the circle. And then semicircles, which the distance that you traveled was exactly half of the circle. Does that make sense? So basically that's what we're talking about. And they don't explicitly say it, so I'm going to say it now so that we all know. Minor arcs are named with two letters, just like a line segment. So in here, like this red one, well, now it's green. We call RS, and then we put a little hat over it, but it's a little curvy hat. Like, you know how when we had a line segment, it was a straight hat over the top? Now it's a arc instead of a segment. So we would call it RS. And just like with a line segment, where we don't care if we flip it around because it's still the same thing, because we live in three-dimensional space where you can't have a negative distance. Same thing here. If we called it SR, we would be referring to the exact same object, and we don't have to worry about like considering whether it's positive or considering whether it's negative. That is true here in geometry, where we think about things from the perspective of real life. Yeah, we're not going into some fancy imaginary situation where we can measure things with negative distance, right? When you get to pre-calc, maybe that'll come up, but here we don't care. All right. So this is minor. A major arc is when we're going around the block to cross the street. We're taking the long way around the circle instead of the short way. So how do I tell the difference between when I start at R and end at S, which way I went? If you're going the long way around a circle, you're tagging another point in the middle so that you show that that's the way you're going. So here, because I'm going the long way around, I'm going to use three letters, and I'm going to tag this point in here to show that I went the long way around. So the long way around, we pick three letters. Same two endpoints, but then you tag another point in the middle. And again, just like when we're talking about angles, remember how angles had the three letters? But we can flip back and forth as long as the point in the middle stays in the middle. Same thing here. We can also call that arc STR, because as long as we kept T, the point we tagged along the way in the middle, it's still the same thing, right? The recommendation I gave earlier, if you're having trouble thinking about how to name these, just make your starting point the first letter, make a point in the middle that you choose the second letter, and then make your ending point your third letter. Then you don't have to like worry about what letters go where. If you're in one of those situations, I'm not exactly sure still, I'm still feeling like I'm struggling, it's a good way to just have a way to do it that you can always keep in the back of your mind, you know? But, you know, as long as your two end points are on the end and the letter you tag in the middle is in the middle, you know that you did it right. All right? That's minor, major, a semicircle. A semicircle here. Is there a semicircle here? This is kind of, we'll say that that's a diameter so that I can have an example here. So here, notice how R and T are opposite on the circle from each other. If you were to draw a line from R to T, it would have to cross through P. I could use some fancy words right now like antipode. That's a word that means opposite sides of a circle, or it's most often used like in spheres. When you're like, for example, if you were to think about where we are right now, if you were to travel through the center of the earth and go to the other side, you'd hit somewhere in the Pacific Ocean. That place is the antipode of the place that we're standing right now. Right? Or like the North and the South Pole are antipodal to each other, right? You go 180 degrees along the circle, that's where you end up. Same thing here. R and T are antipodal to each other. That is not a vocabulary word that like you need to know. This is enrichment. But if you want to name the semicircle, now this is a choice that somebody made, and we're gonna stick with that decision. But whoever it was, long ago, decided, all right, well, semicircles, we'll still use 3 letters to name them. They could have chosen 2, they could have chosen 3. They chose 3, so we're going to follow along with what they said. It is perfectly reasonable for someone to have instead said, hey, you know what, it's a semicircle. I have the choice between 2 or 3. Let's pick 2. The one reason why probably 3 is better is because now you can know which side of the circle you're talking about. If I just said side RT, well, which side is that? Is it going the counterclockwise way, or is it going the clockwise way? So here I would have to call it RST to name it properly, or TSR. We want to. TSR is a company that used to produce Dungeons and Dragons before Wizards of the Coast took over. So if you want to be nerdy, you can call it TSR instead. But now notice, like the major arc here and this semicircle here, they have the same letters in them, right? STR versus TSR. They're in a different order. But notice the middle letter, T, and the middle letter here, S, are different. That's how we know that they're decidedly different from each other. Because this one starts at S, goes through T, and goes to R. This one starts at T, goes through S, and ends at R, right? So that's how we can determine which exact arc we're talking about. Does that make sense? Yeah? We feeling okay about this? Makes sense? Online, we doing okay? Any questions so far? Okay, good. So let's move on and do some practice. So for this section, because they're really lazy about it and they don't tell you one way or the other, we can assume any of these lines that look like they're just like a straight 180-degree angle going through the center like this, we can presume that those are diameters of the circle, because that'll help us know whether we have a semicircle or not, right? Like if they didn't tell us and DOC was like 79.9992 degrees, then it would still be a minor arc. But they don't tell us. And if they're doing something like this, hey, identify if this is a major arc or a minor arc or a semicircle. If it looks like a semicircle, it's a semicircle, right? we can be a little bit loose in that regard. So like here, we want to name the minor arcs. We just want to pick the ones that are less than half the circle. So like AC or CE or ED or DA. And notice, since both of these are diameters, we have exactly as many semicircles as we have little pieces, right? If we tried to combine any of these, they would be exactly 180, and so that would be a semicircle instead of a minor arc, right? Semicircles, we're going to look for the antipodes, and we can be like, okay, from A to E through C, right? So ACE. The next one here, let's keep on going, CED, because that's exactly 180 degrees. Then we've got EDA. And our last one is DAC. Right? Those are the 4 semicircles. Those are the 4 pieces that are exactly 180 degrees. Lastly, the major arcs. We want to know the ones that contain point A. Ooh. So let's start with the easy ones. Let's start at A, right? A, C, D, right? Or you call it AED. It doesn't matter which way you go. A, D, D. All right, we're going from A, we start, we tag C in the middle, and then we land on D. Obviously, that has A contained within it because it's in the name, right? If it's in the name, you know that it's within that. All right, let's start at C now. Well, if we go C, E, A, that's definitely going to have A in it. Let's do E, A, C. Let's start at E, go clockwise, tag A. I could have tagged D, but I'm going to tag A just because it'll help convince me that A is on that arc. You know what I mean? You don't have to. You can call it EDC or EAC. It's the same thing. Remember like how with rays, that second point, any point out there, you can tag that one, and to name it, it doesn't matter because it's all going in the same direction anyway. But I'm going to be specific and call it EAC when I go around, just so I can convince myself. All right, so we started on A, C, and E. Let's start on D. Let's go around D, A, E, right? That contains A too, right? So these 4 arcs all contain the point A, right? Whether it's on the end point or if it's somewhere in the middle, it doesn't matter. It's on that arc somewhere, right? So here's your turn. We'll take 2 minutes. So we want to know, what are the minor arcs of A? What are the semicircles of A? And what are the major arcs of A that contain point Q? So they named the circle A by its center. That's how you name a circle. What's the name of the circle? What's the point in the center? It's usually O. Usually the letter they use is O. They're choosing to use A here for some reason. Alrighty, so one thing to notice with this circle and how it's different than the last one we did is the fact that we don't have as many diameters going through here, right? AS and AQ don't line up. So suddenly we don't have as many semicircles, which means some of those that would have been semicircles are not going to be semicircles anymore. They're going to be major arcs or minor arcs, right? So let's start with the minors. So let's go around the circle like we did before. Each of these four individual pieces, those are all minors. SP, PQ, QR, and RS. Those are all minor arcs. But now also, in addition, notice from S to Q, less than 180. So we also have to include that one. With our semicircle, we've got two semicircles only, right? Because RP is our only diameter line segment. So we're going to look at RSP and then RQP. Right? Those are the only two. Lastly, with our major arcs, once again, it helps us notice that this long way around for SQ is more than 180 degrees. So we're going to also include SRQ. So we've got, and again, you can choose whatever letters you want, as long as we get them to include Q. That'll help us remember. So we can have SQR, PQS, QRP, or you could call it QSP, that's fine as well. And then RSQ, right? Those are all the different chunks of our circle that are 180 degrees or more. Well, not exactly 180, but more than 180 degrees, and include the letter Q in that. And like for the ones where Q is in the middle, like these two. Remember, I don't have to name it with the Q in there. I could call it SPR, right? These are still the same thing. I could call it BRS. These two are the same thing. It's just I tagged a different middle point, right? It's still the same exact thing. Same thing here. These are the same. Cool. Awesome. So let's push forward and let's talk about how to measure an arc and what it means to be the measure of an arc. So when we're talking about arc measure, we're talking about, just like with angle measure, we're talking about in terms of degrees. So we'll talk a little bit later about like absolute measurement. Like if I took a tape measure and measured around the circle, how many inches is that? Here, we're not concerned about that. We're concerned about like relative measure, like how many degrees around the circle are we going? Does that make sense? We're not talking about, so like I could have a circle bigger than this with that same angle measure in there, and that would all still be the same. Do you get what I'm saying? Does that make sense? So like, and I could make this little teeny tiny one, make a 50-degree angle in there, and the measure of this little arc right here would still be the same as the measure of this big arc right here, yeah? Because we don't care about size. We're not measuring in terms of inches or feet. We're measuring in terms of just degrees around the circle. What percentage of the circle are we actually focusing on, right? So basically what it boils down to is if you know the measurement of the central angle, like again, we're going back to pizza slices, right? If you know the measure of that central angle, the corner of the pizza slice, if you know that angle, then the arc has that same angle value. All right? And likewise, if we're going around the circle the other way, if we're looking at this major arc, this is, in fact, 310 degrees, right? 310 degrees around the circle, most of the way around the circle. They're trying to be fancy and be like, well, 360 minus the minor. No, don't worry about that. If you know what the major arc is, work with that. Now we're looking at like reflex angles, angles that are bigger than 180 degrees. And then the other thing that this little piece talks about, if you guys remember, back when we first started, we talked about if you've got two line segments and you smush them together, the total distance for the two line segments is equal to the two pieces added together, right? Same thing with angles. If you've got two angles and you smush them together, the two pieces add up to the whole thing, right? Same thing here. If I were to measure two arcs that are next to each other on a circle, the distance between the two pieces, if you add them together, you get the distance of the whole bigger arc, right? Part plus part equals whole. Still the same thing as it was from the beginning, all right? You feeling okay about that? Yeah? If you know one piece, and you know, same thing with subtraction. If you know you can add things together, you know you can subtract them from each other. So we can do arithmetic around this circle. We can do arithmetic. Sorry, I just had one of those moments as I'm explaining something, connecting to something completely different, and I love it. It's one of the most amazing feelings in the world. You're talking about something, oh, that's why it works. You'll learn about that sometime late in college if you ever decide to pursue a degree in math. But basically, that's what we're talking about. The arc length is additive, just like angles and line segments. So here, we want to know what the measurements of each of the arcs that they have listed. Let's start with BC. Well, we're talking about arc BC. All we have to do is compare it to the angle measure, right? Well, what's the angle measure? Right, it's here. This many, 32 degrees. So if the angle is 32, then the arc measure is 32 degrees. So let's look at BD now. Arc BD, now we're looking at this bigger piece. Well, if this piece is 32 and this piece is 58, the whole thing had better be 90 degrees. Let's look at arc ABC. Well, we're going from A all the way to C. And again, this is one of the reasons I was talking before about how sometimes the book is going to be a little bit lazy about this. They draw the line straight through. This is a straight line going from A to C, right? So we know it's a semicircle, which means that we know it's 180. If they're going to make it not 180, they're going to make it easily noticeable that it's not 180. Like, we know BOA is definitely not 180. It's too small. But if ever you're looking at well, probably, then it is. Okay, that's something that you can be assured of. And if you ever have any questions about it, and you're like, okay, well, I assumed that it was, but then I got it wrong, then that's when you come talk to me, okay? But it shouldn't be. This book doesn't do that. So ABC is a semicircle, so it has 180 degrees. Lastly, they want to talk about AB. Well, here's the thing. You know that ABC is 180, and you know that the piece that is the part we're going to cut off to make arc AB, the piece that was cut off is 32. So all we have to do is be like 180 minus 32, right? Again, like I was saying, if you can add, you can subtract. So this should be 148. With problems like these, don't overthink. Just use common sense. 90% of the time, it's going to be something that you can look at and go, oh, it's obviously this. If it's ever for some reason like super duper non-obvious, you're like, oh, I'm not sure. How could I possibly know this? Let me know, we can talk. But it should always be obvious. Now it's your turn to try. You're going to find the measures of each of these arcs that they give here. All right? Let's go over these. So, measure of angle PR. Well, we know the angle associated with PR, right? Is 77. So if that's 77, then this had better be 77. Remember, the angle measure and the arc length, the arc measure are the same. You don't have to like translate it. Just whatever they are, they're the same measure angle-wise. RS. Well, they're pretty clear that this is a diameter. So from P to S is 180, right? So we can just, if we want to find RS, we can just do 180 minus 77. Should give us 103. PRQ. Well, they tell us, well, we know this part, PRS is 180. This little extra piece is just 28 degrees more, right? So for this one, we can just do 180 plus 28. And then you end up with 208 degrees. PQR if we do PQR, again, we're start at P, go round past Q, and look at R. Well, that's basically the entire thing but that little piece, right? So we could, hey, the whole thing is 360, let's subtract, yeah, exactly, subtract 77, right? And then here, the only trouble becomes remembering how to subtract properly. 300 minus 17 more, so 283. Right? So that's all there is to this. It's just combining all the pieces, or if you have something bigger that you know and you can subtract a piece, you can do it that way. It doesn't matter. Either way is fine. Whatever you want to do, whatever is easiest for you, you're going to still end up with the same thing that I got. All right? So now, again, we did this in the bell ringer, so we know what the circumference of the circle is. Right? Either pi times the diameter or 2 pi times the radius. And again, it doesn't matter which one of these you prefer. That's fine. Or if you're the type of person you have both and then you use them strategically, also fine. It all depends on you. Let's do some, when we're just doing circumference, not that hard. Let's do a couple application problems here. So here you've got this dolly going around filming. And what they want to know is how much further is the outer wheel traveling than the inner wheel. So one of the things, This type of problem is like super duper 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 common. You're going to see a problem like this anywhere you go, anytime they're talking about circumference, because it's super easy to put this together. And all they're asking you to do is find the circumference of the outer circle, find the circumference of the inner circle, and then just subtract the two, right? This is one of those types of problems where they want you to overthink. Don't overthink this. Just do, hey, find the circumference of the bigger one, find the circumference of the smaller one, big minus small, and you're good. So let's do that. First, let's identify the radii of the two circles. The inner circle has a radius of 8, and the outer circle has a radius of 8 plus 2, which is 10. All right? Well, now we know everything we need to know. Here's the big circumference, 2 pi times 10, 20 pi, right? Here's the small circumference, 2 pi times 8, or 16 pi. Well, now all we have to do is do big minus small, and then we have how much farther? So 20 pi minus 16 pi. Well, what's 20 minus 16 is 4. Just don't forget to put pi. Maybe make pi look better. All right. So all we did here is we noticed the two radii. What were they? Well, the bigger radius was 10, the smaller radius was 8. All right, because they gave you the smaller radius and they said the bigger radius was 2 more. Then you use that to do 2 little circumference problems real quick, and then you just subtract them. Here's your problem. Basically the same exact problem, it's just they gave you a different picture and different numbers, right? So here they give you the big radius is 16.1, and here they give you the distance between the wheels is 4.7. These are both in feet. So go ahead, give this a try. Can everybody here see this? I know it's a little dim. Yeah, is good? And because I can tell it's pretty bright on the 16.1 feet for the outer radius from the center to the outer one, and then 4.7 is the distance between the tire tracks. First thing you want to do is make sure you have both the radii, right? The big one is 16.1, their difference is 4.7, so the smaller one should be 11.4 feet. Yeah, that seems right. So all we're going to do from here is just calculate these circumferences, right? Here's the big one, 2 pi times 16.1. And here's the smaller one, 2 pi times 11.4. So we got 32.2 pi. We've got 22.8 pi. And then we just subtract, right? Because it's the same thing. How much farther is the outside one traveling than the inside? So just subtract them. 9.45 feet. There we go. So, like 28 feet-ish, right? This is also, by the way, why you need to get your tires rotated every once in a while when you drive. Because turning one way versus turning the other way, you do more work on one than the others. So you have to keep them rotated so that you keep them wearing in the same way in the same places. Otherwise, you're going to end up having one tire bust faster than all the other ones. All right, we feeling okay about this? right? I don't think either of these problems were hard. They're just sort of kind of tedious, yeah? A little bit of extra writing, but it's still just, hey, circumference, subtract, right? Last thing that we want to talk about now is arc length. So now we're actually talking about, we want to actually physically measure around the circle how far it is, right? So they've got words up here, but the thing that you need to remember, what we're actually doing is we're just finding a percentage of the circle. What fraction of the circle are we doing, right? So we're just going to find the circumference. That's what you know, they give you the 2 pi r and the pi d here. And then this thing right here, we're just saying, hey, whatever the angle is of the arc over the whole thing, right? Part over whole, just so that we can get the fraction that represents the piece that we're working with. Or if you prefer the pi d one. But that's all we're talking about. We're just saying, hey, take the thing here, find the circumference, and then shrink it down by whatever percentage we're working with. Am I working with half the circle, a quarter of the circle, an eighth of the circle, a 50th of the circle, right? That's all we're talking about. Is just, okay, calculate the circumference and then multiply by the fraction that represents the piece of the circle that you're working with, okay? Okay, so let's do a couple problems together. So here we want to show the arc length from x to y here. So let's identify the measure of the arc. What's the angle? Well, it's 90 degrees. This is, you know, we can say it like this, 90 over 360 times, well, the circumference is pi d, so 16 pi, right? But, you know, we're thinking about this as, what part of the circle is that? It's a quarter of the circle, right? You don't need to do 90 over 360. If you, like, you look at it, oh, that's a fourth. Okay, good. You don't have to be extra. Each and every one of you in here, both in person and online, are capable of seeing that, right? So all you're going to do here, well, what's 1/4 of 16? It's 4, right? So that's all we're doing. Now, if you are in a situation where it's like, well, I don't know, what percentage is that? What fraction of the circle am I dealing with? You can always go back to relying on angle over 360. But if you don't have to, you don't have to. You are totally within your rights and abilities to just sort of skip straight to the point. And that's one of the reasons why I wanted to talk about, hey, focus your thinking on the circumference and then take the time to worry about what fraction, right? So let's do this other one. Well, 240 out of 360 this time, right? So the circumference of the whole thing, since this is a 15 centimeter radius, we're talking 30 pi, 2 pi r, right? But then, okay, 30 pi is the whole thing, but I want to know my part. Well, I only get 240 out of 360. And if we simplify that 240 out of 360 down, it's 2/3, right? 24 out of 36, 2 out of 3. Well, what's 2/3 of 30? Well, times 2 divided by 3, we get 20, right? So 20 pi. So here, they just give you words. My recommendation is draw a picture if it helps. All right. So what's the length of a semicircle with radius of 1.3 meters? Leave your answer in terms of pi. So just like we have been doing. All right. So once again, what helps is that we know this is a semicircle, right? Semicircle is half of the whole circle, right? I mean, you can think about it 180 out of 360 if you want, but if you half, right? You can, it's okay for you to jump straight to the chase. It's okay for you to do that. 2 pi r, so 2 times 1/3 times pi, or 1.3 times pi, right? When you do all that, hopefully everybody gets 1.3 pi. And again, leave it in terms of pi. You don't need to turn it into a decimal. Just leave it as 1.3 times pi. So leave it at about 4, right? You don't need to write it as a decimal.